All right, we are live this evening. We are going to give you a minute to join us. We are so excited about you being here today. As usual, this is Work It Out Wednesday. We are here every Wednesday through May. We will be here consistently showing up for you. If you have any problems, please email help at mathematicstutoring.com and we will be happy to answer your problems tonight. Feel free to drop some things in the chat. I will be working out some problems that we have been running into with our students this week, as well as some multiplication strategies. Kimberly, do we have anybody who has joined us on Instagram tonight?
We have 5 and growing.
All right. Well, let's just get into it. We're going to look at this first problems and we're just going to choose what we want to do. All right. So I'm going to look at this first problem here. It says a baker's dozen, and interesting enough, they even put 13 um, in parentheses for us. So they didn't want us to assume it was 12 because it's a baker's dozen. And I'm fixing my camera here. Of cookies is on sale for $13. Is on sale for $4.94. How much does each cookie cost? Okay, so we're trying to figure out how much does each cookie cost. So if we have 13 cookies, we're going to divide that into our $4.94. We're going to move that decimal up here. So we know that 13 is going to go into there 0 times. So what we've noticed with a lot of our students, multiplication is really a struggle, like really a struggle. And so what we have been teaching our students to kind of get it out of their head and stop the test anxiety a little bit or the nervousness of not knowing their facts. We still have some babies that are counting on their fingers in our 7th grade. We try to say, let's get it out of your head. Let's draw a T chart. And so with the T chart, your student can kind of add as well as they can kind of see the pattern of what's happening. So we know that will be 26. And if we go 3 times, if we add 13 here, that'll be 39. If we go 4 times, when we add 13, that will be 52, and so on. We could go to 5 and 13. So if we add 13 under here, that's 5, 65. And now I'm just going to stop there. But to help your student take a little pressure off, you could always do a T chart. And you're just multiplying. That's really 13 times 1, 13 times 2. But they can really use addition because they're adding 13 all the way down. And this just gives our students who really don't know their facts some comfort. What we have found, especially for our middle schoolers, it's not that they don't understand the strategy or maybe what the question's asking, but when they're actually doing the computational skills, they're having an issue with multiplication. So we're going to continue now that we've made a T-chart. It's great because we can reference it. And right here we see 3 times 39, and technically we have 49 here if we exclude that decimal. So we're going to subtract it, and we end up with 10, and we're going to bring down this 4 here. And so we put our 3 up here. And so now we have 104. Well, I stopped at 65, if you can see it. So we're going to just keep going here. So if I add another 13, that's 78. If I add another 13, that's 1 carry our 1. That's 91. And if I add another 13, I was going to add that 13. It is 104 on the dot. And so I just kept using our T-chart and adding 13 all the way down. And so it came 8. So we're going to put an 8 right here. And we're going to get 0. So each cookie is 38 cents. And so this helps because you don't have to guess, oh, what times 13 goes into 39? What times 13 goes into 104? You have made a T-chart to support you as you do this problem. Alrighty. Okay, so the other thing that a lot of our students really struggle with are two-part questions. Okay, two-part questions really get our babies tricked up. So in this question here, we're going to answer question number 4. A florist uses 240 roses to make 8 identical floral arrangements. How many roses would the florist use to make 13 identical arrangements? So we have to know if in 8 we get 240. If we have 13, we'll get how many? Well, we know this has to be proportional. And we can actually work these a few ways. We can divide 8 into 240. To see how much each arrangement is. So we know that 24 goes into there 3 times, and then we'll get 0. So we know that each arrangement gets 30. So and if we have 13, we could do 30 times 13. We also know because these are proportional, we could also use cross multiplication because they're equivalent and it would actually be the same. So you're doing really the same step. So you would be 8x is equal to 13 times 240. And then we're going to get x by itself. So we're going to divide both sides by 8. And so x would equal that 13 times 240 over 8. So, and that's basically what we did over here. So then now I'm going to multiply our 30 and our 13 really quickly. And we have a 0, so we really could just do 0, 0, 0, 9, and 3. So 0. We get 390. So it is 390 in 13 identical arrangements. And then what I would have asked my students here is, does this answer seem correct? Because it's not just, oh, did we get an answer? Because a lot of these standardized tests that our students are about to take, they have tricks. So I'm sure if there was a problem like this on the test, they would have what 8 times 240 is, or 8 divided by 240. They usually have the answer for the first step because that's where a lot of our students will stop. They'll stop at this 30 and move on. Whereas they needed to go to the second step of finding how many for the 13, this 390. And so that's why we also want our students to say, does this answer make sense? Well, it has to make sense because for 8 arrangements, we had 240. We expect something larger because we have 13 arrangements. And not just getting them to see what the answer is, but does it make sense and is it what I'm looking for? Those are the 2 biggest things that they need to be asking themselves as we get into testing season. Alrighty, so we are going to keep going on tonight, and I want to do a multiplication problem, and I'm just going to test it out. One of our students taught us we do this by using what's called the turtle method. And so we are going to do a problem tonight. And then I will jump right in to something else. So we're going to do 36 times 45. And the reason we call this a turtle method is we're going to draw ourselves a little turtle here, the turtle head. So cute. I wish I had a green actually. All right. And it helps us understand that first we're going to use our ones place to multiply. And we always tell our students, remember your place value. That's why we learn it. So we're going to do our 5 times 6 is 30. So we're going to do the 0. We're going to carry that 3. 3 times 5 is 15. 15 plus 3 gives us 18. Then what's going to happen is the turtle is going to lay an egg right here, a big old egg, which represents 0. That turtle just laid a 0. That 0 is there because we're moving place value. Now we're focusing on our tens place. So the tens place gets all the attention out. So that's why that turtle can lay the egg. So then we'll do 4 times 6.
Don't forget the necklace or the tie.
Oh, what's the necklace and the tie?
So to make so that you
Oh,
remember
yeah.
to exit out.
Necklace. You're right. I'm crossing out that we've already used the 5. So I have a necklace on the 5. And I have a tie that crosses out the 3 up top. Okay. This is a very fancy turtle, y'all. I love it though. All right. And then so now our students would do 4 times 6, which is 24. So 4. And we're going to carry our 2 because that tie, we tied it off. We don't need it anymore. And 4 times 3 is 12 plus 2 is 14. And so our little turtle, we're going to add and we're going to get 1,620. And this is how we use turtle method for multiplication. Great way for students to remember the steps, which ones to go first, how to make sure they don't get confused of when they've carried the number and accidentally adding it to the wrong number, and always remembering that 0. That's sometimes a tough concept for students because they don't necessarily recognize that we're just doing a place value change, and that's why we have to drop that egg here. Would y'all like to see one more of these with the turtle method? All right, let's do one more. And then we will go to something else today. So if I do 14 times 37, and let me see if I have a green real quick. Likely I do not. Okay, I'm going to use this yellow. Let's see if y'all can see it. Oh, you can't. Ooh. So I drew myself a turtle. Alrighty. So we're going to start off with 7 times 4 is 28. So 8, and we're going to carry that 2. And then 7 times 1 is 7 plus 2 is 9. So we get 98. Then we're going to put a necklace on our turtle because our 7 is done. And we are going to lay an egg here, drop that egg for our 0. And then now we're going to go to our tens place. So 3 times 4 is 12. So we'll do a 2 and we tie that down and carry our 1. 3 times 1 is 3 plus 1 is 4. And then we add. We get 8, 11, carry our 1. We get 518. Alrighty. And yes, I love color coding in math. It helps us to remember what goes together, helps keep us organized. And even though a lot of our tests are online, they have colors online. And students should definitely try to utilize those colors and always ask for paper. Pencil to paper is a strategy. I tell my babies that all of the time. Alrighty. We are on a roll. Let's head on over. Kimberly, anybody had any questions for us today?
No, just viewing.
All right. So I'm going to get started with an area question. Hopefully y'all can see it. And I'm sure for some of my adults, I'm sure you remember. And if not, we're going to dust those cobwebs off tonight. The area equation. And we always tell our students, reference your reference sheet. Go to whatever formulas they give you. And it is A equals pi r squared for area. That's usually the formula that students are given. So first, I want to start off by talking about some misconceptions here that are very important for our students to make sure they understand. R squared, I'm going to circle that. R squared is not, I repeat, is not 2 times R. That is not what R squared is. And a lot of students make that mistake and get this wrong. R squared, and I like how this teacher taught it, but they got to make sure that our babies understand that when you see the square sign, this is what it means. It means R times R. So whenever a student sees R squared like that, they can write R times R and now make their own new equation. A equals pi R times R, because those are the same things. Because that's what squared means. It means we're multiplying a number by itself. Okay, well, we're going to look at our picture here. And do we have radius? No, we have diameter because it goes all the way across. Well, we know that radius is equal to the diameter divided by 2. So we just split that diameter in half. So half of 8 is 4. So here we're really saying pi of 4 times 4. And so we know that 4 times 4 is 16 pi equals A. Well, we see we have decimals here. So they actually want us to solve for pi. And I always say reference your reference guide, or if they give you the number, let them know make sure your students know what that number is. For Texas here, we use 3.14 is equal to pi. So now what's important here is that our students can multiply this decimal times a whole number. So I wouldn't call this like a crazy strategy or anything, but it is a method that I coach my students on because this is a place where we make mistakes. How many places do we have behind that decimal? 1, 2. So I tell them to write 2DP. What does DP stand for? Decimal point. It's just a quick way to remember it because they're going to multiply like regular. So we're going to multiply. 6 is 8, 18. We're going to drop that 0 for our turtle. They could do their little turtle method here. 1 and 4, 4, 1 and 1, 3 and 1. And then we're going to add. So we get 4, we get 2, carry our 1, 8, 9, 10, carry 1, 3, 4, 5. And I'll tell you, a lot of teachers tell students, oh, pretend that decimal's not there and just multiply. Then our students get here and they don't know what to do. Or they say, none of my numbers look like that. But that's why we put this 2DP. It means we need to move our decimal point 2 times. And we all know the decimal point is imaginary and in the back after we multiply. So we get 50.24. And it's just a good reminder. As well as when you have multiple numbers. So say we had 3.14 times 7.5. Well, now would a student know how many times we need to move that decimal point? Well, if we label it, yes, we have 2DP and we have 1 decimal place here. So 1DP. So 2DP plus 1DP means 3DP. So we need to move our decimal point 3 times when we multiply this number. So this is just a great way, and easy, takes 2 seconds to remind our students of how to move our decimal points. And while in your mind you might be like, oh, area, perimeter, circumference, these are such simple concepts. But there are ways that students make small mistakes from misconceptions. And these are how, between moving your decimal point, remembering that squared is not multiplied by 2, and remembering that diameter is not radius. A lot of our students will go take this 8 and they're going to plug it in, find the answer, and I bet you it's one of these answer choices. Every time. That is how they trick our students. But it goes to show that the students have a lack of understanding somewhere of how these things relate. Kim, you got anything for me? You look like you're reading something. Oh, thank you, thank you, thank you. Alrighty, I'm going to work another one. Let me pick it out. Let me pick it out. I wanted to work a circumference, I think, here. Let me see where's the. Okay, we have a circumference down here. So let's go here. Let's go here. The circle has a diameter of 30 centimeters. Which measurement is closest to the circumference of the circle in centimeters? Well, I know that circumference, which is, and we're going to make sure everybody knows this, circumference is like perimeter. It's everything on the outside. Area is everything on the inside. So that's the difference. So we're talking about that outside layer here. And the equation is just pi times d, or pi times diameter for circumference. And so this one, we're just plugging in. So we'll do pi times 30 because we already have that diameter. And then again, here we go. We're doing 3.14 times 30. And we know that we have 2 decimal places. And since we're multiplying by a 0, we're going to put our quick 3 zeros, dropping a 0 here. This one was a rather easier one that I chose here for us. And then we're going to move 2 decimal places. So our answer will be 94.20. I will tell you, these problems get tricky when they give us the circumference and they ask us to find the diameter, or they give us the area and they ask us to find the radius, and getting our students to figure out what that is. So I challenge you that if you have any students in the 7th grade, to challenge them to try those things out for sure. Kim, do we have any requests for tonight? Any requests? Thank you all for watching. We definitely appreciate it this evening. You got anything for me, Kim? No? Okay.
We've been talking about doing a series of, like, for our Texas people, basically going through the release star questions. If you are from Texas and you are watching, go ahead and let us know if that's something you would be interested in, because we've definitely been talking about it. We can do other states as well. So we've been discussing that. So definitely, if you are maybe you're in Florida, Georgia, Massachusetts, and you have a state level test that your students do end of course, and you would love for us to do a live where we dedicate to that, or drop in a few questions, let us know.
Absolutely. We would be so happy to support for sure. I'm looking, I'm deciding what else we're working out tonight. And we're open to take any requests tonight. If anybody has any requests, we have about 5 more minutes that we're going to be on live, and then we're going to be heading on over to TikTok today. Okay, actually, I want to do one of my my favorite strategies. Turning a fraction into a decimal is one of my favorite strategies. It is. Yeah. Um, and you know what? I'm going to do this one because so many people get tricked up on this. Where is my paper? Oh, there it goes. Alrighty. So I wish I could share my screen. What if we wanted to take, I'm in New York with a 5th grader. Okay. All right. So what if we wanted to take 0.05 and make it a fraction? So what we want to do is tell our students first, how do we look at our place value? So we want to know, let's use this orange. What place value is that last digit in? Well, it's in our hundredths, right? So what we can do is take this and put it over a hundredth because it is hundredths. And then what we're going to want to do, we are going to want to simplify or reduce. And so we can say, I always tell my students for these, look at 2, 3, and 5 first, because typically numbers can be split in half by these or divisible by these first. So 2s are usually for our evens. Can't do that for this. 3s can't do that, but 5s, yes, we can. We have something that ends in 5 or 0. So 5 goes into 5 one time. 5 goes into 100 how many times? Well, 5 divided by 10 is 2. And then to 0, we get 1/20 is our fraction. Now, what if we want to go from fraction to a decimal? Okay, so let's take that same 1/20. And I tell my students, and this is my favorite method, and if you've been watching us, you might know it. Hope you do. It's called TIBO. And it stands for top, inside, bottom, outside. So our top, or our numerator, is going to go inside here. And our bottom denominator is going to go on the outside. And then we are going to divide. Well, 20 cannot go into 1. So we're going to add a decimal point and a 0 here. And then we're going to add a 0 here. So can 20 go into 10? Absolutely not. So we're going to add another 0. And just so we can see it, that'll give us back our 10. We'll have a 0. We'll bring it down. Now, how many times does 20 go into 100? 5. And so that is how we go from fraction to our decimal. And then the last part of this is we like to know, now, how do we go to a percentage? And so old school way is we move our decimals 2 times. 1, 2 to the right to get 5%. And so this is a skill, learning how to go from fraction, decimal to percent. One of our middle school / it could be 5th grade for some as well, strategy for sure. Do you have regular tutoring sessions? Yes. At Ski Web, we do have regular tutoring sessions. We offer one-on-one tutoring online, actually, and we have a pool of tutors that we match your student with, and we tutor 7 days a week. We're very flexible. If you go to our website, www.mathematicstutoring.com, and you can press to schedule a consultation, and we could get you set up to learn more about our services, for sure. And we will be happy to support. Well, you guys, this is all for tonight. We are going to go ahead and hop onto TikTok. If you want to join us on over there, we will be happy to see you. Thank you for joining us again on Work It Out Wednesday. Or comment consult in our DMs, and it'll give you a direct link to our Work It Out Wednesday. Yes, yes, yes.
Thanks for joining us. Bye.
Bye.